This lesson is for Chapter 2, Section 1, Linear Equations in Two Variables. It starts on page 160 in your textbook, so if you want to get that open and get your notes open to a new chapter, we'll get this lesson underway. So one of the models that you've been used to with linear equations is a slope-intercept form of a line, or y equals mx plus b. I think that's going to sound real familiar to all of you. Recall, if you have an equation in y equals mx plus b form, m, or the coefficient of x, is the slope. Recall that slope is the rise over the run for your line, or the change in y over change in x is sometimes how that's referred. And the b, or the constant at the end of the equation, is called your y-intercept. So if you have an equation in y equals mx plus b form, it's ready to graph. Okay, so a lot of our things we switch into that form because of the ease of it. When you're looking at graphs of lines, you can identify slopes simply by how the line is oriented. So on these four pictures that I have here, a positive slope increases from left to right. A negative slope falls. Slope of 0 is horizontal because your rise is 0. Rise over run would give you 0 over a number. 0 over something is 0. The vertical lines are the undefined one because our run is 0. So a number or a rise over 0 is undefined. Okay, remember that zeros and denominators get that undefined mark. So if we were going to sketch this linear equation, y equals negative 3x plus 2, our intercept is 2. So I know that this line is going to cross the y-axis at 2. I can go ahead and graph it. My slope is a negative 3. In rise over run format, just simply put it over a 1. Now that rise over run tells me to go down 3 and right 1 to get more points. You could also go up 3 and left 1. So we could look at this slope as a 3 over a negative 1 as well. They all line up, and we have the graph of our equation. Graphing a equation, or an equation that has just one variable, be thinking horizontal and vertical lines when you see these happen. Okay, so your y equals a number lines, your x equals a number line. Those are going to be horizontal or vertical. So your task is to remember which one is which. Well, here's my hint for you. Here's my help. Y equals negative 3. The first spot, the easiest spot for y equals negative 3, is the negative 3 on the y-axis itself. Okay, now the graph of this line, y equals negative 3, is going to be every other value, or every other point that has a negative 3y value. So if you think of going vertically, okay, ask yourself, is the value of y still negative 3 if I go up? Then that would be no. So now you know you're not going to do a vertical line. Check a point to the side. What about this point here? That's the point 3, negative 3. My y value is still negative 3. Try one back here. That's the point negative 5, negative 3. My y value is still equal to negative 3. So if I take the collection of all of them, I end up with this horizontal line. That is the graph of y equals negative 3. If I graph this one, or if I'm asked to graph this one, transitioning it into a y equals mx plus b is the fastest way to graph. So looking at what's given to you, you've actually been given a standard form of equation, ax plus by equals c. So there's a couple, or one main term out of place. The 4x is on the wrong side. So move it, subtract 4x from both sides, and the equation quickly transforms into y equals mx plus b form. So now looking at this, my intercept is 5. Graph it. My slope is negative 4, or negative 4 over 1. So go down 4, right 1, and we have the graph of our line. Now if you need to find the slope of a line, okay, a couple of different situations they're going to throw out you. Um, One might be finding the slope given 2 points. Okay, so if they tell you that 2 points lie on a line, find the slope so you can eventually write an equation of the line. Slope formula is on the slide here. Change in y over change in x. Your rise comes from your y's. So y2 minus y1 over x2 minus x1. This is your rise over your run. Okay. Now notice you can consider either of the 2 points your first points or your second points. So when you're determining what one's going to be, x1, x2, or x1, y1 versus x2, y2, you don't need to worry about getting that wrong. You can take either the first point or the second point as the first in your slope formula. It won't matter. You'll be fine. So let's do a couple. If we have these 2 points on the line, what's our slope? Okay, so my y values, 8 and negative 6. So 8 minus a negative 6 is my rise, change in y. 2 minus a negative 5 is going to be my change in x, or my run. So on top, I have 8 plus 6. On bottom, 2 plus 5. So 14 over 7, or a slope of 2 over 1. Okay, so the slope of that line would be 2, or 2 over 1. Point B, let's take a look at that one. My y's, negative 1, negative 1 minus a minus 1 for my rise, and 3 minus 0. Well, on top I've got a negative 1 plus a 1. And I think most of you guys could see that. Your rise went from negative 1 to negative 1. It didn't change. Makes perfect sense that we're getting a rise of 0. So that one, it has a slope of 0. We would end up graphing a horizontal line with that one. Other than y equals mx plus b, or point-intercept form, or slope-intercept form, we also have a point-slope form in which we can write linear equation. Some people like this one to use as a setup. Okay, sometimes this one is considered easier to load, and then it's a real quick couple of algebra steps to get us into slope-intercept form. Okay, so in point-slope form, the format is y minus y1 is equal to m times x minus x1. Now m still stands for slope. x1 and y1 are represent a point that's on our line. So let's take a look at this one. Write an equation in point-slope form for a line containing the given slope and point. So thinking about our model, fill in what you know. So here's our point, right? And of course, m is equal to 2. So y minus a minus 7 is equal to slope times x minus 3. So simplify. Y plus 7 and 2 times x minus 3. Here's the point-slope form for our given line. Now, we're going to do, in this example, we're going to show how easy it is to go from the point-slope form and get it into slope-intercept form. Okay, so if we were going to do point-slope on this setup, plug in your information. Y minus 1, slope of negative 2/3, x minus 1, distribute the 2/3. Move your constant over to the other side. And there's y equals mx plus b. So it's not a difficult switch from one to the other. So instead of filling in the point and the slope into y equals mx plus b, solving for b, writing the equation using, sometimes this is just easier for folks to understand. Okay, so this might be an alternative that works for you to come up with an equation of a line. Parallel lines and perpendicular lines, these are things that you guys have studied in the past as well. Parallel lines are lines that have identical slopes. Perpendicular lines are going to be lines that have negative reciprocals for slopes. Okay, so taking a look at that, write an equation of a line that's parallel and perpendicular. We're going to do two different examples on this slide. If we're given a point of negative 3, 1, and a given equation of 5x minus 3y is equal to 9. All right, so first thing we're going to do is we need to figure out the slope of the line that we're starting with. Okay, so they gave us, or we were given, 5x minus 3y equals 9. So let's switch that around a little bit. Divide away the negative 3. And we now have our y equals mx plus b version of that given equation. From that, I can see that the slope of our given line is 5/3. Now, we don't want our new lines to land right on top of that, so our intercept isn't going to stay the same. We have to figure out what our new equation is going to be for a parallel line. Okay, so if the equation of the line is going to be parallel, I want to use that same slope again. But I want it to pass through the point negative 3, 1, instead of through points that go through that given equation from up above. So using the information that we have, plugging it into the point slope form, y minus 1 equals slope times x minus a minus 3. So y minus 1 is equal to 5/3 x plus 5. Move the 1 over. Y is equal to 5/3 x plus 6. There's an equation of a line parallel to the one that we were given. Okay, how about if we wanted one perpendicular to it? Well, we don't want to reuse the same slope. We don't want 5/3. If it's going to be perpendicular, we need a slope that's a negative reciprocal of that. So the slope we want for the perpendicular line is going to be negative 3/5. Okay, we still want it to pass through negative 3, 1, so we're going to keep that. But let's load it up now into our point slope form. So y minus 1 equals negative 3/5 times x plus 3. Distribute. Add 1. So y would equal negative 3/5 x minus 4/5. And there would be an equation for a perpendicular line to the given. Okay. Turn to page 166. I didn't want to retype this entire question, so please turn to page 166 for this problem that we're going to do. The one that we're going to look at goes along with example 5 at the top. Slope is a ratio. Okay, it's rise to run. So it makes sense that we can use the concept of slope to do a comparison or a ratio in one of these problems. Okay, so in this problem, we're talking about building a handicap accessible ramp. It says the maximum recommended slope of a wheelchair ramp is 1/12. A business is installing a wheelchair ramp that's going to rise 36 inches over a horizontal length of 32 feet. Okay, so I'm on the checkpoint one, but it's still using the same wheelchair ramp ratio, 1:12, from example number 5 up above that's in the book. Okay, is that ramp going to be steeper than recommended? All right, so we know we need a 1:12 ratio for rise to run on the wheelchair ramp, which is approximately 0.083 repeating. Okay, so let's take a look at our example in the book. it tells us that it's going to have a rise of 36 inches to a run of 32 feet. When we're looking at ratios, we want to make sure that our units match. So the first thing I notice in this ratio is that they don't. 36 inches is a pretty easy conversion to feet. So I start by rewriting. Okay, now it's just a matter of comparing it to that 1 to 12 ratio. If we do the decimal form of this, we get roughly 0.09375. That is a higher number than the 1 to 12 ratio that is required for a wheelchair ramp. So this one is in fact going to be too steep. They cannot use that rise to run ratio. Okay, so that's one example of how slope can come in helpful. It can also be used as a rate of change. Okay, so take a look at this example that I put up on the board here. If an accounting firm determines that the value of a copier T years after it's purchased is V equals negative 300T plus 1500, describe the significance of the y-intercept and the slope of this line. All right, I think you guys know that after you buy something, it's no longer worth the purchase price. It depreciates. That's what that word means. It's going to go down in value the longer you own it. Okay, so when we're looking at this equation, value is equal to negative 300t. Well, t is time. Okay, so by looking at this, negative 300 is in that slope position, correct? Okay, so it's telling us that each year, okay, if t is 0, machine's brand new. Plug in 0, you still have it worth $1,500. That's its new price, $1,500. What happens after a year? Well, if we plug 1 in for time, that means we're going to deduct $300 off of our $1,500 looking at this equation. We're going to end up with $1,200. So our 1-year-old machine is only going to be worth $1,200. So back to the question here, describe the significance of the y-intercept and the slope of this line. Okay, well this number here is the y-intercept, right? Okay, 1,500, that's the start price. Because when t is 0, the value is 1,500. So that machine starts out being worth 1,500 bucks. The slope. Okay, this tells us that it's going to depreciate or reduce by $300 each year. Now, you guys are good enough math students to know that after a certain number of years, this machine's not worth anything. Okay, so that's another piece of information that's looked at, is how long before this machine would need replacing. Okay, well, according to the model, after 5 years, the machine's going to have no value any longer. Well, whether that's true or not, maybe it still runs, probably keep a copier, but technically, after that 5th year, your value is 0. If something goes wrong, probably time to get rid of the machine. So let's take a look at this depreciation problem in the book. I'm in the bottom page 167. It says a manufacturing firm purchased a machine with $24,750. Okay, the machine has a useful life of 6 years. After 6 years, the machine will have to be discarded and replaced. That is, it will have no salvage value. It's worth nothing. Write a linear equation that describes the book value of the machine each year. All right, so first of all, we know the machine started at $24,750. Okay, it tells us in our passage here that it's going to depreciate each year. Okay, and it tells us that after 6 years it's going to be worth nothing. So if it goes down in equal increments for 6 years, let's figure out what it's going to drop per year. Okay, so if we divide that up evenly, we're going to find a depreciation of negative $4,125. Okay, So how would you show that it's going to go down $4,125 per year? Well, negative 4125t. The starting value was 24,750. So at t equals 0, you can see that your value is going to still be equal to that 24,750. Then after 0, each year you're going to deduct that another 4,125 from it. So here's our linear equation to show that depreciation. Turn the page to the next side. Okay, on page 168, it says the sale for Nokia were approximately 58.6 billion in 2009 and 56.6 billion in 2010. Predict the sales in 2013. All right, well, we can use our years and our approximate sales kind of like ordered pairs. Okay, so let's use 9 to represent 2009, and that paired with 58.6, and 10 for 2010, and our sales there were 56.6. Okay, we want to predict what's going to happen in 13. Okay, so we're wondering what's going to be right here. Well, let's use our slope. Okay, so if we do change of y, or rise, we'd have 58.6 minus 56.6, whoops, 6, not 5, and then 9 minus 10. Okay, y minus y, x minus x. So we end up with 2 over negative 1, or a negative 2 slope. Then we can use one of our points to fill in here so that we can come up with some kind of a linear equation. You can use either of them. Okay, either this one or this one. You can choose the x, y that you want. I just picked the top one. So in setting up our linear equation, I'm using point slope form again. I just like that one a little bit. So y minus 58.6 would equal negative 2 times x minus 9. Okay, so start solving. Move the negative 58.6 to the other side. And we get this equation. Now it asked us to predict what's going to happen in the year 2013. Well, 13 would be your x value, correct? So plug it in. So we get negative 26 plus 76.6, or 50.6 billion. Okay, so that gives you a couple of samples of things that you can use slope for outside of graphing. Your assignment begins on page 169. I just want you guys to do a nice random sampling of problems in there like we've been doing. Don't neglect some word problems, all right? So take a look at the word problems that are on page 171 as well. That's all I've got.